Okay, by way of revision for direct proof, I'm going to give you an example here, and the example that I've chosen to do is question 3 from the 5 questions that I set you on Mattermost, and this is the practice class test number 2 question, the one that I set you last week. So let's read the question. Consider the sequence. Notice that this is consider the sequence of numbers 1, 3, 5, 7, 9. Firstly, notice that it's a sequence and not a set. So it has order to it. Prove that the sum of any 3 consecutive elements, so that's another word to note. It's not any 3 elements, it's 3, one after the other. Prove that the sum of any 3 consecutive elements of this sequence is an exact multiple of 3. So that means it's 3 times some integer. So the first thing that we need to do with any proof like this, with any direct proof rather, is we put it into if P then Q form. That helps us to think about the proof. These are the known facts, and this is what we're going to try to prove given these known facts. So we say, if A, B and C are 3 consecutive elements of the sequence, then, so here's our then part of the statement, there's our if, then, or what can we say? We say that A plus B plus C is equal to 3 times some integer k, where k is a member of the integer set Z. Okay, how do we go about this? Well, we can't go about it at the moment because we don't know the form of A, B and C. Clearly, if A, B and C are just 3 random numbers, they won't necessarily be equal to 3 times k. But they're not 3 random numbers, they're 3 consecutive elements of this sequence. So what we need to do is we need to use the form of A, B and C to prove that this is the case. So what form do they have? Well, in general, there's a general formula that we can use for the nth element of this sequence. And we can work out what this is by looking at it. I'm going to start my numbering at 1. So that's the first element. That's the second element, the third, the fourth and the fifth. And in general, I'd like to know what the nth element is. Let's call it element n. Okay, so the first element is 1, the second is 3, the third is 5, the fourth is 7, the fifth is 9. What formula can I use for the nth element? Well, by inspection, it's going to be 2n minus 1. That will work for all of these values. So take the value 4, 2 times 4, that's 8, minus 1 is 7. So the nth element is going to be equal to 2n minus 1. Great. So now what I need to do is to use this formula in here and see what happens. So element A, where does it occur? Well, let's just say that it occurs, is the kth element, where k here is a member of n0. Sorry, n1, And also notice I used k up there, so I'm going to use a different variable. Let's call it j. J is a member of n1. Element A is the jth element. Whatever it is, I'm going to call it the jth. Okay. So A is equal to 2j minus 1 because it's the jth element. Okay. Question is, what will B be? Well, basically, it's going to be the next one after this. How do I get to the next one? Well, I could go by 2 of j plus 1 because B is the next one after it, so therefore it's the j plus 1th element. And C is going to be the j plus 2th element. So because these are 3 consecutive elements. Starting with the jth element, just some arbitrary j somewhere along the line, and then the next one after that, which is the j plus 1th, and then the next one after that, which is j plus 2. So all we need to do now is to add them up. So the sum is going to be equal to, well, it's going to be 2j minus 1, that's the first one. Then it's going to be, well, let's do some simplification here. So it's going to be 2j plus 2 minus 1. So I'm just multiplied out that bracket there. And then this one is going to be 2j plus 4 minus 1. So that's my sum there. And then if I add all this up, well, all the j's, we've got 2j, 2j and 2j. So that's 6j in total. Then we've got minus 1. And then here we've got a plus 2. So that's plus 1 overall and a minus 1 there. So that's 0 so far. Plus 4, so that's 4, and then minus 1. So overall, all of these add up to plus 3. So the sum is equal to 6j plus 3. I'm trying to show that that's 3 times an integer. So I will rearrange that, take the 3 out of the bracket, and then I've got 3 times 2j plus 1. And because j is a member of n1, that means I've got 3 times an integer. So in other words, this is equal to 3z, where z is a member of, I certainly know it's a member of the integers. It'll actually be a member of the natural numbers. But it's 3z, where z is a member of z. That shows it's in that format, and I am therefore finished with the proof.